Alright, this guy's just a little bit harder than the last one. Not incredibly hard. We're going to look at this cube root function. And one of the things that can change with a cube root function is, well, you can get the cube root of a negative number. So for instance, if I'm plugging in these x values into the cube root of x, I know the cube root of negative 8 is negative 2, giving me the point negative 8, negative 2. Cube root of negative 1, well, negative 1 multiplied by itself times 3 times gives me negative 1. Give me one of our critical points that we're going to use to graph negative 1, negative 1. Cube root of 0, 0. Giving us what we're going to eventually call, right, another critical point, but also the point of symmetry. Likewise with a positive number, cube root of 1 and 1. Cube root of 8 is 2. Giving us points on the other side that match that those points that we graphed. Ooh, positive 8, excuse me, positive 2. Match the points that we graphed on the other side. And there is our graph. 0, 0, 1, 1, 8, 2, which it looks like I graphed at 8, 4. I should have done that a little lower. 0, 0, negative 1, negative 1 right here, and negative 8, negative 2, which again I graphed a little high, but you get the point of the graph. Alright. The domain. Well, you know what? This has no limits. We didn't have to restrict the domain. So now my domain goes all the way from negative infinity to positive infinity. And although it doesn't ask it, oh, it does, domain. Let's list range as well. My range goes all the way down to negative infinity, although it doesn't do it very quickly, does it? And all the way up to positive infinity at a much slower rate. Alright. And we're going to point something. It does have point symmetry around the point 0, 0. Right? And there we go. If I rotate it around that point, this point would come to here, right? This is a basic function that is a cube root function, and now we're going to learn how to graph it. I'm not going to pause. I'm going to keep going. It's only been 2:20, and I'm going to show you how we change it. Now, these points, again, we're going to try and move just our critical points, and if you remember, right, every time we change an x and every time we change a y, there's something predictable. Well, when I change the x values, I multiply by h, or b, and add h. So 0 times b is, well, 0. B plus h is h. 0 times a, remember, a and k is what affects our y value. 0 times a is 0, plus k is k. We can do the same thing we did before, right? So when we had 1, 1, 1 times b is b, plus h. Over here we multiply by a and add k. 1 times a is a, plus k. Same concept over here, except now we're multiplying by a negative 1. This is b and h. Negative 1 times b is negative b, plus h. Negative 1 times a is negative a, plus k. And that's how we're moving our critical points. And if you look at it, it's really not too bad. So let's do this. Alright. So we already know h right here is 3. We know our k is 5, and it gives us an a value of 2. Since there's no b, we assume it's 1, right? So one of our critical points, 0, 0, turns into h, k. Basically, we take that point here and move 3 to the right, and 1, 2, 3, 4, 5. You know what? I'm missing the scale. 3 to the right's right here because it's a scale of 2. And 5 up is 1, 2, 3, 4, 5 right there. And let me go ahead and erase this and go ahead and write my 5 in. Alright. And look, we're going to change our points. Let's change 1, 1. We take that x value here, multiply by b, which is still 1, and add h, so that's plus 3. Take our y value there, multiply by a, which is 2, and add k, which is 5. For a new point, which is 4, 7. So let's go 4, 5, 6, 7, right about there. Alright. Let's do the same with negative 1, negative 1. Take this first one here, it's times b, right, plus h. So negative 1 times b is negative 1 plus h plus 3. Alright. This guy right here is times a plus k. Negative 1 times A is negative 2 plus K plus 5. Gives us the point. It looks like 2, 3. So we go to 2, 3. Alright. And then we follow the trend of the graph. We realize how this graph trends like that. And we're good. Excuse me. Let's do one more. Alright, or two more even. I'll probably just do one and let you do the last one. And we'll move on from there. So I go here. Let's locate our graphs. So it looks like we have A in this case isn't listed, so it's 1. Let's list B. Looks like B is 2. Remember, it's always this guy flipped over. H in this case is 10. And K is 4. So that gives us our point of inflection, right? Yeah, our symmetry point, they're going to call it, which is H, K. Alright. Let's put that down. 10 is over here, 4 is right there. Looks like our scale's by 2 again. Alright. So we're going to get a few more points. Well, let's look at it. We'll plug in 1, 1. Alright. 1 times B is 2, plus H, that gives me 12. Alright, 1 times A is 1, plus K, that's 4. Alright. Oh, actually did the math here instead of just writing an H of 10. Please forgive me. Once again, that's B plus H, which over here gives me 12 and 5. Let's try the other one. Negative 1, negative 1. Alright. This guy right here times B plus H. Negative 1 times B is negative 2 plus 10. That's my H value. This guy right here times A plus K. Negative 1 times 1 is negative 1 plus 4. We get 8, 3. So let's see. Those should be somewhat similar distances from this. So we got 12, 5 right here. 8, 3. That looks pretty good. Looks something like this. We're going to graph our points. I'm going to leave this guy to you. Same stuff. Follow the same steps we did. Take those 3 critical points. Locate your A, B, H, and K. I will write the rule, even though we've done this a few times. X, Y. Alright. Every time you change an X, it's X times B plus H. Every time you change a Y, it's Y times A plus K. And I'm going to let you try C. Alright, you guys.